Testing, 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 testing. Hi folks, so here's the deal. I made a 1-hour video for you on Scratch, and then I realized that my microphone wasn't working, so I'm doing a narration over top of the video. Hopefully I can remember what it was I was doing. What we're doing today is I'm going to show you a program called Scratch, which is used to introduce you to programming and logic and algorithms, which are basically just step-by-step instructions. So what you're seeing right now is the Scratch window. You can find the link in our class section on this. It's in Unit 3. And what you see on the right side of the screen is Scratch the Cat. That's where all the action's going to happen. And the mouse right now is in the coding section, which is where we're going to put all of our blocks. It's a drag and drop environment, so we're going to be able to drag the blocks on the very left side of the screen over into that middle part, and we're going to be able to program what we want Scratch the Cat to do. This programming section is part of the technology integration for the Math 9/CCA 9 course. I'm going to make it optional. It's something I think you should do because I think it'll improve you both by introducing you to the Scratch programming environment, but also by showing you some logic things that'll help you with math. So right now I'm just dragging out some blocks to show you how you drag programming blocks into the main area, and Scratch the Cat there on the left, he'll do what we ask him to do. So there's all these options on the very left side that will show us or that will allow us to do various programming activities that are going to help us move Scratch the Cat around and get him to do stuff. You can grab him, you can drag him. These are called sprites. Every character is called a sprite. You can add new sprites down here. There's all sorts of different characters. You can draw your own, you can paint over things. And so you can have multiple characters in the screen if you want, and we'll do that later in the video. So if we go over to the costumes section here, it's just showing you what the costume for Scratch the Cat looks like. You can change them, you can draw over them. There's two costumes for Scratch the Cat. One of them is the way he's pointing now, and this is the other one. So between the two costumes, you can kind of make it look like he's walking. It defaults to the first costume, and I'm going to show you a little bit later how you can switch between the costumes to make it look like he's walking. Just showing you the coding area again. Okay, this is how we start every program. We drag this block out that shows you a green arrow, and that's basically how you start the program. There's a green flag up top there. And every time you hit go, it'll do something. Right now, Scratch isn't programmed to do anything, so he's just going to stand there. Okay. There's the go button. And again, Scratch is doing nothing because we haven't programmed anything yet. So going to this motion tab over here, there's all these things you can do to move Scratch and turn him. Get them to go to a position, you can get them to go to a specific spot on the screen if you want. And pointing in a certain direction, moving toward the mouse pointer, that sort of thing. Now these blocks kind of click together, so when I drag this move block, I snap it underneath that one. It usually just kind of snaps by itself if you get it close. And there's a turn 15 degrees button. You can change that to whatever you want. You can turn them 90 degrees. And then you can move them again. It'll just do these steps in order from top to bottom. So you see if I click the green flag there, Scratch moved and turned and moved a bit more, but it happened so quickly that you didn't really see what was happening. So what I'm doing now is I'm going into the control section, and I'm going to grab the wait 1 second. And I'm going to grab another one, and I'm going to put it in there. So he's going to move, wait, turn, wait, move. Now you'll be able to see it happening. You see there he moved, and he turned. Because I put that 1 second wait in there, it's just a little easier to see what happens. Most of the time, your programming the computer reads it so quickly that you don't necessarily see what's going on. You notice Scratch the Cat's upside down right now. There's a way to fix that. If you go into the direction section down below, there's an option right in the middle at the bottom, left, right, and that just prevents him from turning upside down. So now he'll only stay right side up no matter what we get him to do. So he's moving, he's turning, he's moving, and that's all we had him doing in our programming section. If you try to move Scratch out of the screen, when you restart your program, he's going to end up there. So I always like to put these two blocks at the beginning of my code, like right under the green flag thing. I like to put a go to and a point in direction. You notice the go-to has X and Y coordinates. I'm going to make those both 0, and that just puts them right in the middle of the screen. You may have seen this in elementary school. It's called the Cartesian Plane. It looks like a big plus sign. There's a vertical line and a horizontal line. So anything up and down, 0 is the middle. Anything plus, like y equals 5 or something will be above, y equals -5 will be below, x equals -5 will be to the left, x equals +5 will be to the right. I think there's about +200, -200 in all directions for this screen. So the point of me putting that in is if I end my program there, but I've got these go-to and point as my first 2 steps, every time I hit the green flag, he'll go right to the middle of the screen, and then he'll make sure he's pointing right, which is 90 degrees. Well, there he is. When I click the green flag, he goes back to his starting point. Then he'll do his regular programming stuff, and then whenever I kick the green arrow again, he goes right back to the beginning. Okay, so we're just going to drag these out for now and get rid of them, and we'll do something else, maybe a bit more interesting. Scratch is back in his default position. So we're going to try to make a little program here. If we go to Control, there's all these little holder blocks. And you just drag those out. This is a repeat. That one will do whatever you want forever. This one has an if statement, so there's a little condition that has to be met, and if that condition is met, then it'll do whatever's inside the block. Okay, so we can just drag those out and put them sort of wherever we want. We'll start with this repeat 10. So whatever it is that we want to do, we're going to put it inside. Okay, we're going to put it inside, and then it's going to do that 10 times. So it's basically a loop, right? It does those 2 things, then it loops back up and does it 10 times. I'll take those out because I don't want those inside my loop. Let's put something else inside the loop. Let's move Scratch 10 steps. Then we'll turn Scratch 90 degrees. And now, instead of moving 10 steps and turning once, he'll do it 10 times. So I'll put a little weight in there just so you can see what's actually happening, so it doesn't happen too quickly. Okay. So now instead of moving 10 steps, he's actually going to move 100 steps total because we're doing it 10 times. And then he turns as well. So anything inside that repeat 10 section is going to loop. Everything outside it is not going to. So you can see he's moving, he's turning, he's moving, he's turning, and he's going to do that 10 times because I've got a repeat 10 on there. So he's moving, turning, moving, turning. And then every time I hit the green arrow again, he's going to go back to where he was. Right back to the starting point. And then he'll do his little steps 10 times. So really in total he moved 100 times, right? 10 times 10. You can drag stuff in and out of the blocks. You drag blocks around. This time, instead of a repeat 10 times, I put in forever. So our program's actually never going to stop here. He's just going to keep moving and turning, moving and turning, moving and turning, moving and turning forever, because I told it to do it forever. So the only way to stop this process is now to hit the stop sign. So that'll actually end your program. Okay, I'm going to drag those steps out, and we'll do something maybe a little different. Okay, we still got a forever loop in there, so whatever we're doing inside that is going to happen forever. Let's go to switch costume. This allows you to switch between the costumes that your sprite has. Some sprites have 2 costumes, like Scratch here. Some sprites have many more costumes. Scratch the cat is pretty simple. Let's use this next costume block. And what that does is it switches between, it just goes down to the next costume on the list, and when it gets to the bottom, it goes to the top again. So if we do forever, you notice Scratch the cat just switches between those costumes, and it kind of looks like he's walking. So if I wait a second between costume changes, oh, I'm waiting 0.2 seconds, 0.2 seconds. He walks a little bit slower. Let's grab this 10 steps, and we'll drag that in there. So now, forever, he's going to change his costume, wait 0.2 of a second, and then he's going to move 10 steps every time. So now it actually kind of looks like he's walking. But we don't have anything programmed to tell Scratch what to do when he hits the edge of the screen. So he's just going to keep walking into the edge of the screen forever. So we're going to obviously have to fix that and put some more code in. I just hit the green arrow there so it goes back to the starting position, then he'll walk to the wall and just keep running into the wall. There's this little code here called code block called if on the edge bounce. So if we put that inside our program, every time he hits the wall, he's going to bounce, which causes him to turn around and just move the other way. So this program, if we run it forever, he's just going to run, hit a wall, and then when he hits the wall, he's going to bounce, turn around, and start going to the other wall. So he'll just do that forever. Just keeps bouncing. It detects where the walls are when you've got that code in, so it knows at a certain x, y value that I've hit the wall, and now I need to turn around and go the other way. And because it's doing it forever, basically this is the only way to stop the program. All right, we're going to drag that program block out. Anything that's in this code area is kind of fair game, but it won't do it unless it's actually inside that green, when green flag clicked. So you can just put programming blocks out there if you know you're going to need them later and save you going through the menus. Okay, so now let's get some input. We've got this little thing down here that we can put in to say when a key is pressed that Scratch can do something. We're going to build some logic that says if the key is pressed, do this, essentially. So I think that's the next thing I did on this. We'll see in a second here. Pull those out. And we're going to go and set a logic condition. So I'm going to bring in an if-else statement. Okay? And what this means is if a certain condition is met, say if you're pressing a key, then it's going to do one thing. And that's right below it. If it doesn't do that thing, let's say you're not pressing the key, then it goes down to the one below and does the else. It'll only do the if or the else. It will not do both of those things. So I've done what's called nesting. I've put that if-else statement inside the forever, so it's just kind of like nesting inside. So whatever's in the forever is going to happen forever. In this case, the if statement is in there. I don't have any logic for the if yet, okay, so I need to put some sort of condition in there. If what? Okay, right now it's if nothing. So if this key is pressed, we'll do something. And you can change that key to whatever you want. Let's just make it the right arrow, right? So if you're pressing the right arrow on your keyboard, then what do we want it to do? We got to put that right underneath. All right, so if you're pressing the right arrow on the keyboard, let's just make him move right. I think that would be logical. So we've got to point him in a certain direction. He's already pointing right, but he might not always be pointing right, so we'll take another copy of that block and put it in there, make sure he's facing to the right. Then we'll do the next costume, wait, and we'll have to put a move in there as well. So we'll move him 10 steps, and when we're pressing and holding down the right key, you notice how he walks toward the wall, and as soon as you stop pressing the right key, he will stop moving. Okay? And it'll do that forever, as in, if you are holding down the right key forever, he will move to the right forever. But only if you're doing that. That's what the condition was for. Let's move him 100 steps, and you'll see that he jumps a lot. So what we're going to do is we're going to tame that down a little bit. Maybe we're going to get rid of that wait. Now that we've got an if statement in there, it'll run a little bit slower because it always checks if you're holding down the key. So now he's walking pretty quickly. The video didn't really kind of capture how fast his legs were moving. But if I move it 10 steps at a time, moving pretty quickly. So we've taken care of what happens with the right arrow. Now we need to take care of other keys as well. So in the else statement there, well, what happens if that's basically what happens if we're not pressing the right arrow. We're going to need another if statement. So you put in another if and another else, and we're going to nest this inside the else portion. So we're really like 3 layers in now. So we've got the forever is the first level, the if is the second level, and then this little thing inside the else is the third level. So you just keep nesting things inside forever if you want. So let's do a different direction now. You can either go drag another one of these, or you can just right click and duplicate it, and then just put it inside that little section there. And Probably change that from right arrow to left arrow. Okay, so now we're going to take care of what happens if the left arrow is selected. Okay, accidentally move that block there, just move it back. We can copy these instead of going to find them in the menu again. Go to duplicate, and then you can just drag it inside. The way it works is that if you duplicate something, click on the top part, the top of the top block, and it'll duplicate everything underneath it. Here I'm just going to change in the direction, so I'm going to make the direction left, which is -90. Okay, so left arrow, we're going to turn to the left, is all that does. And then the same thing, we're going to do next costume, and we're going to move. So if I press to the right, he goes right. If I press to the left, he goes left, and he should be changing costumes, which kind of makes it look like he's walking. So now we got left and right taken care of. Probably going to take care of either up or down next, can't remember. So we're going to throw this in, the else for that one. Now we're 4 levels in. Okay, we started with forever. That was 1, if is 2, inside the else is 3, and now inside that other else is 4. So I'm just duplicating everything again, because really not much is changing, right? So I'll just duplicate this, put it inside the if block, and that last one. I got to change it from left arrow to probably up. And then now the direction, instead of left, I got to face him up, which is 0 degrees, sorry. And now we've got 3 directions, right? Left, right, and then we can go up. Can't go down yet, though. We haven't programmed down. Now, theoretically, you could put down in the else statement there by just using an if block. That's probably what I'm going to do. Because we've got 4 directions. We've already taken care of 3. So if it's not any of those 3 directions, it must be the 4th, right? Yeah, it's sort of. What would happen if I, press the A key? What would happen if I press the S key? Well, we're not sure. So this wasn't actually a brilliant idea to throw this in the else. I'm changing it to down, and I changed my mind. I'm like, yeah, that doesn't work very well. So I'm actually going to drag that out, and I'm going to put another if in there. I don't need an else this time because I've taken care of all of the 4, so there shouldn't be an else. There should only be 4 options, right? Up, down, left, right, and down. So this last one's down, and it's just the if block, not the if-else block. So I'm doing what I did before, duplicating it. Now this one's going to be the down arrow, and I'm going to grab this chunk of code, put it in there. Now our direction needs to be, I believe, 180. So all the way down, 180. And then we don't need to change the next costume or move, because we do want him to move. We just want to know which direction we're moving in. So now you should be able to go up and left and down and all over the place. So you can move Scratch in all the major directions. And they don't have to be the up, down, left, right keys. You could make it the A, S, W, Z keys or whatever you want. Where it says key right arrow there, you can make that the S key and still have them turn 90 and move if you want. So that's a little tutorial on movement. All these blue ones are basically the, what can we sense, where can we go? A glide is an interesting one. So this one will glide to a random position forever. It'll just keep going all over the place. He just keeps gliding, and the computer keeps picking new spots on the screen, and there he goes. You can also change that right there to the mouse pointer. And now he's going to glide and try and follow wherever my mouse is. So, if you're making a little game, that might be a nicer way to move Scratch than the arrow keys. Totally up to you. Okay, so I'll stop that. And I think we're going to build a little math program now, if I remember correctly, since it's a math class. So we're going to set variables. Variables in math just stand in for numbers and letters and sentences and words in Scratch. We're going to use it for numbers because we're going to be doing some math programs. So what we're going to do is we're going to make a variable, and we're going to call that variable exposition, I think? Yeah. So the point of this program is we're going to move Scratch to wherever you want him to move. So we're going to have 2 variables because we need to know the horizontal, which is the X value, and we need to know the vertical, which is the Y value. So we're going to have the user type in where do you want Scratch to go, X and Y, and then the program's going to have Scratch the cat move there. So we're actually taking information from the user, and we're going to use it to send Scratch somewhere. And that location can be different every time because the variables can change. That's the point of variables. Whenever I have variables in a program, I always set them to 0 at the top of the program before anything else runs, because if you have information in there from a previous time you ran the program, it's gonna work based on those. So I always take the variables, and you'll notice I hit the drop down menus to change it to set X position to 0, set Y position to 0. So whenever we start, Scratch is going to go to 0, 0. He's going to point right. The X position is going to be 0, and the Y position is going to be 0. Not just the X and the Y, but those variables are actually going to be 0 and 0. And you can see them there on the screen in those little boxes. So it just resets the program every time. All right, we're going to throw a forever in there. And instead of gliding to the mouse pointer, we're going to get rid of that. And I think we're going to glide to a different place. But first we have to get some information, because we don't know where to glide yet. We need to find out where you want them to move. So we need to find the ask and answer blocks, which clearly I forgot where they were. I'm looking around here. Where's that ask and answer block? Got to be here somewhere. And yeah, I'm totally in the wrong place, by the way. It is in sensing. Just scrolled past it. There it is. Ask and wait. So we're going to take that. It's in sensing. Third time's a charm. We're going to take that, and we're going to throw that in our forever loop. So forever, he's going to ask you, where do you want me to go? And we need to get two pieces of information. What's the X position? And now it's just waiting, and eventually we're going to get an answer. So it's waiting till it gets an answer, and you can see answer on the left side underneath the ask, on the very left side. So we got to set those variables to whatever your answer is. So I'll probably just drag an answer out there for now. Okay, so now we have to set our variables to whatever your answer is. Okay, so I'm going to set the X value. Instead of to 0, I'm going to go back and find my answer block, and I'm going to put answer in instead of the 0. So I ask you a question, you give me an answer, and I set my X position to whatever that answer is. And it can be different every time you run the program. And now I'm going to have to do the exact same thing for the Y. So I duplicate those, put them underneath, and now instead of what X position, I'll say, what Y position do you want? And then I'll change the Y position to the answer. Each ask has a separate answer, right? So the answer is going to change based on what you type in. Put question marks in there. So we've taken care of, at this point, we've taken care of all the resets, and then forever, he's going to ask you what X to go to and what Y to go to, and we're going to store those in variables. We haven't actually moved Scratch there yet. We've just asked you where you want him to move. So now we got to go to the motion, and we'll throw a glide in there. So we'll throw a glide 1 second to whatever X and Y we want. Currently it's set as X0, Y0. We don't want him to go to 0, 0. We want him to go where you wanted him to go. So we have to go to the variables section. And those variables will be whatever you typed in. So we got to replace those two zeros there with whatever you wanted the X and Y to be. We go back to variables, and you can see there's an X position and a Y position box. Let's grab those two little chunks. We'll go to X position, which is what you typed in, and Y position, which is what you typed in. So now Scratch should glide there, and then because it's running forever, it'll just keep asking you X, Y, and keep moving them. So what X position do you want? You just type it in and hit enter, or hit the check mark. So let's say 200, and that will change the X position variable. And now what Y position do you want? 350. So now when I hit when I hit enter, it's going to do the glide to that position. I sent him a long way, so he's basically kind of out of the screen. So we'll maybe rerun this program and put in some different values. We went to wherever, he went to the X and the Y that we asked. 200 is pretty much the top of the edge of the screen on the left side. What Y position, negative 100, sorry, I just put in two new values there. X negative 100 and Y negative 20, and he glided there. And then I did it again for 050, and he glided there. So you can do it forever, right? He'll just keep asking you what X, what Y, and then he'll glide to where you want him to glide. Because it's forever, it'll keep doing it until you hit the little stop flag. Okay, so now we're going to do a different program. So it's for me, it's easier. You could save them, by the way, up in that file menu, and you should save them. But I just went to a new one because we're going to do a totally new program now. We're probably going to do a little bit of math now. So the start of the program, I always bring out when green flag is clicked, go to 0, 0, point in direction 90, just so he starts out in the same spot, facing the same direction every time. And now we're going to look at the actual section in my classroom. So there's Scratch Program 1. Build a program that asks the user for a number and then tells you the square of the number. We're actually going to build a program that's slightly more complicated than that, but we'll start out with a square and then we'll move on to different exponents. Square being, some number, some base to the power of 2. So what we're going to do is we're going to have you give Scratch a number, and then Scratch is going to compute the answer and he's going to tell you what the answer is. So we need a variable first, and we'll make a variable called base. Okay, so that'll be the big number. And then we'll create another variable that's called the exponent. Okay, so we've got a base and an exponent variable, currently set to 0. And if I haven't done it already, at some point I will probably drag in a set base and set exponent to 0 and put it at the very top of the program. All right, we're going to repeat whatever we're doing twice. So we're probably going to get you to put a base and an exponent in, and then he'll give you an answer, and then it'll do it again, so it'll do it twice. So let's ask, what base do you want? What is the base? And then it'll wait. So now we're going to have to set the base variable to whatever your answer is. So we'll grab set base to, instead of 0, we want to set it to whatever your answer was. So we'll go back and grab the answer block, drag that in. So we're going to set the base to whatever you put in for your answer. And I'm going to duplicate that, and now I'm going to do the same thing for exponent. I'm going to say, what is the exponent? And I'm going to set the variable there, exponent. Make sure you change that, right? Because I'm setting the exponent this time, not the base. And then I'm going to have Scratch. We're just going to test this out. I'm going to have Scratch tell me what my base and what my exponent is, just to test my program. So instead of saying hello for both of those, we're going to go back to our variable section. And I'm going to say, instead of saying hello, say what my base is for 2 seconds, and then say what my exponent is for 2 seconds. We haven't actually done any math here. We're just getting input from the user. So what's the base? And I'm typing in 4. And then what's the exponent? 2. So he says, that's your base, that's your exponent. It looks like it's working properly. And of course, it's going to do it forever. Or sorry, it's going to do it twice because we've got to repeat 2 on there. Okay, so it's just going to ask for a new base and a new exponent, and it's going to change the variables accordingly. So I've got another say in here. I'm not sure what that's going to be. Oh, that's probably going to be my answer. The answer is, okay, all that block does is say the answer is. It doesn't actually compute anything. And then I'm going to need another one to say what my answer is. So he tells you what the base is, tells you what the exponent is, and then he says the answer is, and then he's going to say what the answer is. But we have to figure out what the answer is first, based on what we know about our variables. So we're going to go to probably green here and figure out what the math is. The green section's for math operators. Okay. See at the top there, you've got the plus, minus, the star is for multiplication, and the backslash, forward slash, whatever that is for division. So that's how we can do some math. You can get it to pick random numbers. You can get it to test whether a number is greater than or equal to, all the stuff you can do in math. So instead of saying hello, I'm going to say what the answer is squared. I'm just going to skip the exponent variable for now. I'm going to say base times base. Well, that's a square number, right? So if I do 4 times 4, it's going to be 16. Right? 4 times 4 is 16. If I put in 6 for my base, it'll do 6 times 6 is 36. So I run my program here. We're just ignoring the exponent variable for right now. What's the base? The base is 4. Okay. What's the exponent? 2. And then it's going to go, the answer is, or 4, 2, the answer is, and then it's going to go 4 times 4, because that's base times base, is 16. And then it's going to ask you again, because we asked it to do it twice, right? We ignored that block. For now, we just used base, because we're going to have to get a little bit more complex with our programming if we want this thing to work for anything other than base times base. Okay, so we're going to get a little bit more complicated. Now, it tells you, see how it remembers what the base and the exponent are? Okay? So that's why I'm putting these set base at the very top of my program. Set base to 0, and I also want to set the exponent to 0. And what that does is every time I restart my program, it'll just change the base and the exponent to 0 again, so we're starting fresh. Because you don't want them to remember anything from program to program, or from the time you run the program to the next time. Okay, so it always resets his position, his direction, sets the base to 0, sets the exponent to 0. Now let's make it so it actually works with the exponent. Okay, so this is going to need to be a little bit more complicated. Okay, we're going to make another variable called running total here. And this is just going to keep track of what our answer is. Because we don't have an exponent in the green section, there's nothing for an exponent. So we actually have to do it just using multiplication blocks. So we're going to have to do base times base for square. And then if we want to do it to the power of 3, well, we know that that's going to be the number times itself 3 times, right? So if it was 4, the base was 4, we'd have to go 4 times 4 times 4 if we wanted to do the power of 3. If we wanted to do the power of 4, we'd have to do 4 times 4 times 4 times 4. So we've got to basically repeat that a certain number of times because there's no exponent operator available in Scratch. So we've got to be a little bit creative with it. And that's what we're going to use our running total for. So we're going to do, if we need to do 5 cubed or 5 to the power of 3, we will do 5 times 5 and put that in the running total, which is 25. And then we'll do the running total times 5. So 25 times 5 is 125, and that's 5 to the power of 3. So that's why we need the repeat in there, is because we're going to have to repeatedly multiply by the base to get our exponent value correctly. How many times do we repeat? We repeat the number of times that's in the exponent. There's actually a little logic mistake in there, but we're going to run into it and fix it. So let's go to exponent, and we'll drag the exponent into the repeat block. So you see the repeat 10, we're going to replace 10 with exponent. So if you say I want a base of 5 and I want an exponent of 3, it's going to do this 3 times to get us the answer. And that's actually a tiny little logic mistake, but we'll fix it. So I'm going to repeat this math that many times. So we're going to grab our set variable. Oh, I just grabbed this. I grabbed the running total and set it to 0 at the beginning of program. So it resets all 3 of the variables at the beginning of the program. Okay, so we get a base, we store it as base, we get an exponent, we store it as exponent. We say them for a couple seconds each, and then we're going to repeat it however many times you said for your exponent. Not sure why I dragged that out. Okay, so we're going to repeat it that many times. Probably just repeating how to use a variable here. We're going to use our running total to keep track of how many times we've multiplied, right? So if we need to multiply more than once, say we have to multiply 5 times, we just keep the running total going, and then just keep multiplying the running total by whatever the base was. Okay, why are we going to sensing here? What are we doing? Operators, there we go. So we've already got the... I think I was showing you what the equals was in here, but we don't end up using it. This is more for testing logic. If something is equal to 50, or if something is less than 50 or greater than 50, that's what we would use that block for. Okay, so I just grab my running total, and I'm going to take my running total times my base. Okay. So it's going to run exponent times. I think this is me right here figuring that I do not actually need that block. So hopefully I'm getting rid of it in a second. All right, now we're going to set our running total to the base. Because 1 times, or the base times itself 1 time is just the base, right? Let's think of it this way. If your base is 5, 5 to the power of 1 is just 5. So the first time that this program runs, it just sets your running total to 5 to the power of 1. So your running total is just going to be 5 or 4 or whatever you set your base to. Okay. Again, I don't really need that block, so I'm probably going to get rid of it pretty quickly here. Go to my operator. I need the multiplication one. Getting rid of it. Realized I don't need it. Okay, so I have in my exponent set my running total to. Okay, currently my running total is set to my base, but my running total is how I keep track of my answer when I'm going through each of these loops. So I'm going to set my running total to my running total times my base. So it's updating that running total all the time until it gets to the final answer. So my answer is going to be my running total times my base as many times as I need to. And this is just going to keep updating it. It's not giving you the final answer. It's just telling you this time through the loop, your running total is this. Okay. So I'm probably going to run it here pretty quickly and then try to troubleshoot the problem. It's going to run exponent times. And some of you may have already picked out what the problem is of running it exponent times. Repeating it twice. Everything inside that's repeating twice. It's going to ask you your base. It's going to store the base in the variable. It's going to ask you the exponent. It's going to store the exponent in the variable. It's going to set our running total to base just for the start, right? That would be the base to the power of 1. So 5 to the power of 1 is 5, and 18 to the power of 1 is still 18. So that's why it's doing that. And then whatever you have for the exponent, it's going to apply the multiplication every time and keep updating that running total. So it's all about, using the running total to give you base times base times base times base. And the exponent is the number of times we need to run it. Sort of. Like I said, there's a little logic error there that we have to fix. This is me just trying to tell you what's happening in that bottom section, but I've described it a couple times already. All right, let's run it. So what is the base? Let's put in 4, and then for the exponent, 2. So we know the answer is going to be 16 at the end, right? But watch what happens when we run it. It's going to say the running total is, then it runs it once for 16, and then it actually runs it again because I've got repeating it twice because you put in 2 for the exponent. So our final answer there turned out to be 64 when our program stopped running. But we know that 4 to the power of 2 is not 64, it's 16. Which means this program is actually repeating 1 too many times. So if you look at where it says repeat exponent, because we took care of 4 to the power of 1 right above that with the running total as the base, set running total to base, we actually need to run it 1 fewer times than exponent. So running an exponent will actually put it to a higher exponent. So when we did 4 to the power of 2, our final answer, 64, was actually 4 to the power of 3. So we've got to put in just a little bit of a logic fix to take care of that. It's always going to be the exponent minus 1. It's always going to be the exponent minus 1. And the running total will change because every time it runs that repeat, let's say if you have 4 to the power of 5, it's got to run that repeat 5 times, well actually 4 times, and it's going to give you a running total every time, even though it's not done. So I think at some point here I'm going to put in another say at the very end that says your final answer is this. But we know it's working if the program is running and when it stops, whatever it says in running total is the right answer. So currently it's not the right answer because I'm repeating it 1 too many times. So I'm going back and I'm going to grab a minus block, so that's the second one there. And instead of repeating the exponent, I want to repeat the exponent minus 1. So if your exponent is 4, I actually need to run that repeat part 3 times. So that should fix our logic error. So right above that, we set the running total to the base. So that's basically to the power of 1. And then as it goes through the repeat, it'll do to the power of 2, power of 3, power of 4, depending on what you put in the exponent. So let's run it. Our base is going to be 4. And this time our exponent is going to be 2. Same thing as last time, but this time it'll run properly. So now when we run it, the running total is 16, and then it stops. It doesn't do it to 64. And then it asks you for another one because we told it to repeat twice. So we're going to run the whole program twice. So basically the program's done. our running total is the correct answer, so we fixed that logic error. And it's asking us for another base because we told it to run the whole program twice. So we'll do 5 this time to the power of 2, so we should get 25 this time, right? 5 to the power of 2 is 25, and then our program stops. And we've repeated the whole thing twice, so that's basically all we told it to do. So now that program's done. We've only dealt with exponent of 2 so far. So what happens if we run an exponent different than 2? All I'm doing here is I'm taking our forever loop, and instead of just running the program twice, I'll run it forever. So as long as you're willing to put in a new base and a new exponent, it'll run forever. So what's our base? 5 and to the power of 3. So it should give us a running total of 25 first, because that's 5 to the power of 2. And then we multiply it by 5 one more time, and then it'll get to 125. So it'll give us a running total of 25 first, but then it knows it needs to do it one more time. So 25, that's 5 squared. And now multiply by 5, that's 5 to the power of 3 is 125, and there it should stop. And then it asks you for a new one, right? So it ran it, it got the right answer, and it said, okay, now let's do another one, because we put that forever block in there, so it's going to run it forever. So we had to put exponent minus 1 in there to fix our little logic error. It was running one too many times. Now it's perfect. Okay, so we've got a running total. So it just kind of keeps you posted every time it goes, the exponent goes higher. So, you know, it starts out as 5. It doesn't display the 5, but then it'll tell you 5 squared is 25, and then 5 to the 3 is 125, and then 5 to the 4 should be 625. So it kind of keeps you updated. And again, at the end here, I think I put in a say that says your final answer is, just so it's a little bit more clear. So our exponent this time is going to be 4. So it's going to run this thing. It's going to give you 3 running totals. So there's 25. And then 5 to the power of 3 is 125. And now 5 to the power of 4 is 625. And that's where it stops, because we said 5 to the power of 4. 5 is our base, exponent 4. And it stops when it gets the right answer, and you know, and then it tries to run the whole program again because we told it to. So this is just me at the very bottom putting in your final answer is. You could set another variable for the final answer if you wanted, another orange one, but you don't need to, because at the very end the running total is the final answer. So if I just put the running total in this, the final answer, the first block there just says the final answer is, and then the second block will say whatever the number is, and that'll be hopefully the right answer. So if we put in the base is 10 and the exponent is 2, our final answer should be 100, because 100 to the, or 10 to the power of 2 is 100. That's our running total, but it'll also say the final answer is 100. If I put in something other than 2 for the exponent, now we'll do 10 to the power of, so 10 to the power of 3. It'll give us a running total, but it'll also tell us our final answer. So the running total is 10 squared, which is 100. Now the running total is 10 to the power of 3, which is 1,000, and that's also our final answer. So it'll say the final answer is 1,000. We're going to do a big base this time, and to the power of 4. And we're going to get a really weird number up there. Look at how huge that running total number is. And it's just going to keep doing that. I stopped it because I needed to explain what those numbers mean. Okay. So there's my big number to the power of 4. So our running total is that. And then it's that. So that's squared. And then it's power of, are we at power 4 yet? That might be power 4, and then the final answer is that. Okay, that looks like a small number. It looks like 4.69. You can see it up there in the running total, 4.694. But there's a mathematic notation at the end here that you'll learn later in high school. But basically, it's that number with 42 zeros. So it's a really, really big number, just written in a different way. So if I do, what is that? 10 to the power of 8. That should be, our final answer should be a 1 with 8 zeros after it. It needs to run 8 times, right? So this is 10 squared. This is 10 to the power of 3. It's just keeping you updated. This is 10 to the power of 4. 10 to the power of 5. 10 to the power of 6. I'm not touching anything right now. This program is just running 10 to the power of 7. And then finally, 10 to the power of 8. And that's when it knows to stop because our exponent's 8. So the final answer is 10 to the power of 8. And then it'll ask you for another one because it'll ask you forever. Once it's done doing a question, it'll ask you for another base and another exponent. It'll just run forever. Okay, so I junked that, junked this, and then probably very shortly I decide to just start a new program to get rid of all the other stuff. Make sure you save your programs. I didn't save any of these, but it's up there in the file menu. You can save it. So it's saved to your computer. So I'll just start a new program. So I got rid of all my variables, got rid of everything I had. Now what I'm going to discuss or show you how to do, I think, is broadcasting. Okay, so I'm just putting in my normal, when the program starts, go to the center of the screen, point right. And I think I'm going to have a different character in this one because I'm going to broadcast something and have another character pick it up. I'll show you that in a second here. Oh no, this is where my keyboard stopped working. Yep, my keyboard stopped working. I was trying to change that 0 to a negative number. And my keyboard was just not working. So I think I stopped the recording here briefly to fix it. It let me do the arrows, but it didn't let me change anything with my keyboard, which is super weird. And then miraculously, it just fixed itself at some point, so I have no idea what happened there. Grabbed another one to see if that would work, and clearly that didn't work, so I went, okay, I better just... Oh, let's try again. Let's try typing here. Nope, didn't work. Okay. For whatever reason, my keyboard's not working. I said I'm gonna pause this and try to figure out what's going on. Here's me ineffectually trying to fix my keyboard, failing. So I stopped the program there. Then I got it to work again. And then I said, okay, now what I really want to do is I want to start Scratch on the left side of the screen. So that's what the -104 is, because he's going to be talking to someone else. So I wanted to have room for the other character. So when I start the program, he starts there instead of in the middle. Okay, did my normal point in 90 degrees. That's pointing to the right. So wherever I move him, if I start the program again. Now this code is only good for Scratch the Cat. So I'm going to put a different character in here. So choose a sprite. And I think I pick Avery. There's Avery. So Avery is currently pointing the wrong way and is probably a little too close to Scratch. Now in Scratch, you can see he's got his code. But when I click on Avery, there's nothing there. So each character has their own code. Okay, there's Scratch's code. Avery's got nothing. So I'm going to go over to Avery, and I'm going to put in the same sort of code that I had for Scratch. I'm going to put in the green flag event, and I'm going to put in the you're going to start at a certain position. So I want Avery over on the right side, so I'm going to have a positive 100 probably. Not negative 100. I need to be positive 100. And then Y0. And then I'm going to point Avery, instead of pointing right, Avery needs to point left. So I'm going to point Avery left. And there we go. So now, oh, Avery went upside down. Remember, we fixed that in direction. So in direction here, there's little arrows right there, left, right. That'll prevent Avery from flipping upside down. So whenever I start my program, that's where my two characters are going to start. And I'm being kind of picky here because Scratch is floating in the air, so I decided, well, let's play with these X or Y values, rather, to move them down a little bit. So let's try -75, I think. And then I figured that's way too much. Okay, so let's go back and tamper with this. This is really me just being obsessive about it. Okay, a little more. 28. Oh, that's not much of a movement. Keep going. Come on, Dunbar, keep going. Type in -42. Why would I do -25 again? I just did that. That was silly. Maybe I was just showing you up and down. -35. Nope, still not enough. Keep going. There we go, -42. There you go, that's pretty close. Alright, so whatever the ground is, Scratch and Avery are both standing on the ground. And then I think I decided that the ground wasn't enough. I was going to put in something else that they could stand on. And I was looking for street. You can use the search function. There's no street. Okay, I'm looking for ground. There's no ground. That's too bad. Now I just got to scroll through the list and find something they can stand on. I decided I didn't want them to stand on a bowl of cheesy poofs or a fox or a goblin. So I'm just scrolling down, scrolling down, scrolling down, and I settle on a truck because I got tired of looking. So there's a truck. I want to make the truck bigger though. So you can go into the costume section and change a whole bunch of stuff about the truck if you want, but there's actually a size button. I don't know why I was hovered over delete. I didn't delete it. There's actually, I went back to code and then there's a size button there, so I made this 200 so the truck was twice as big. Not 200,000. 200. There we go. So yeah, the truck's kind of out of the screen there, but I just wanted to have something for them to stand on. Then I think I got picky again and said, well, Scratch isn't quite touching the ground, so I went back and changed his Y value to -45 or something like that. -44. And then I decided, okay, that's close enough. Scratch is pretty much on the bed of the truck, and so is Avery. So they're standing on the truck. None of this was actually the point of this particular exercise. I was just showing you how to put sprites in and how each sprite has its own set of code. So when I restart the program here, because I told Scratch and Avery to go to specific spaces and point in specific directions, every time I restart the code, they go back to where they were, which is standing on the bed of the truck. Okay, now I'm probably describing broadcasting. Broadcasting is when you send, just like a radio, you send a signal out to the entire program, and our signal is going to be called number. And the whole point of this program is we're going to get you to type in a number, and then we're going to broadcast that it's Avery's turn. And what Avery's going to do on her turn is she's going to pick up that broadcast, just like a radio would pick up a radio signal, and she's going to add 1 to your number, and then she's going to tell you what your number plus 1 is. So I'm going into sensing, and I'm going to ask you, the user, what number you want. What is your number? And I'm going to wait, and I got to set a variable, right? So my variable was number. I already created that. First off, I'm going to set it to 0 at the very top of the program, so it resets every time. Then I'm going to set the number to whatever the answer was. Remember, for every ask, there's an answer. There's an answer. So now we set the number to whatever you typed in. Okay. Currently it's 0, but it will change based on what you type in. So we're just going to test that. What is your number? 5. And then we'll hit enter. Should have hit enter. 5, hit enter. Then the number up there you can see is 5. So we tested it out. We know it's working. Now what are we going to do with that number? Okay, we're going to send a broadcast right now. So we're going to basically set up our radio station tower, and we're going to broadcast something. We're still in Scratch's sprite here, because Scratch is the one asking the question. So in the events section, there is something called broadcast. Okay, there it is, broadcast. And there's a broadcast and wait. And I'm going to use the broadcast and wait because I don't want Scratch to do anything after he sends this message. So after he gets the number, he sends the message and says, I have a number. And then I thought to myself, well, that's a stupid thing to broadcast. Maybe I should broadcast Avery's turn or something like that to make it a little bit more clear. Right now, all he's saying is, I have a number. He's not sending the number anywhere. He's just saying, I have a number. And I decided that was stupid. I'm going to broadcast Avery's turn. So basically, I'm telling the program, it's Avery's turn. And then somebody had, that's the signal I sent out. But now Avery has to receive that signal. So now we're going to go to Avery. We're going to go to Avery's code by clicking down here on her section. All we have Avery doing right now is going to a position and pointing a direction. So we have to put some more code in for Avery to receive the broadcast and do something with that broadcast. So we are going to stay in events, I would think. Yep. And now I'm pulling out a second block that says when I receive Avery's turn. So I'm going to have 2 blocks of code here, and that's fine. You can have as many blocks of code as you want. So the new one is when I receive Avery's turn. So when I receive the message on my radio that it's Avery's turn, okay, there I send it right there. And now when I receive it, I want to do something. Well, I want to take that number and I want to add 1 to it. Okay. And we know what the number is because it's stored in our variable, which is called number. So we're going to say, instead of saying hello, we got to say your number is, or your number plus 1 is. Then let's go say again, and instead of saying hello, we're going to say what the number plus 1 is. We need some math there. We need addition. Grab the addition block. Then we got to take our number, whatever number you typed in, and then we've got to add 1 to it. So we'll take that whole thing and put it in instead of hello. So we're going to say your number plus 1 is, and then it's going to say what the answer is. And then, I think I'm showing you here, is there is an end block in control. If you want to end your program after a certain step, stop all will stop the entire program. So at the end of our program, Avery has just said your number plus 1 is the answer, and then the program will end. So I'm just going to move these guys around to show you. When I start the program, they go to their right spots, pointing the right direction, and the number resets to 0. What's your number? Okay, our number is going to be 9. Then it broadcasts Avery's turn. Avery receives the broadcast, says 9 plus 1 is 10. Program ends, nothing else happens. Do it again. What am I going to broadcast? I'm going to broadcast Avery's turn. Avery picks up the number, it says 12 plus 1 is 13. Okay, so it sends the message, Avery's turn, Scratch does, and then Avery picks it up and says, okay, I'm going to take that number, I'm going to add 1 to it, and then I'm going to stop. I drag the stop out. I think I want to just add a little wrinkle into this. I said, let's move the truck out after Avery's done, let's just move the truck out of the screen. So, after Avery's turn is done, I'm going to have her broadcast move truck or something like that. Truck moves. So there's actually 2 broadcasts in this now. Scratch broadcasts Avery's turn, and then when Avery's done her turn, she says, now it's truck move's turn. So now Avery's the radio tower, and Avery says, I'm sending you a message. Okay. I'm just bringing the start out for the truck, and I'm gonna put the XY there. That XY is actually where the truck is right now, so I don't have to change those numbers. Just kind of puts that in there automatically for you. And I probably should put in a point in direction right. I don't know if I did or not. Yep, I did. There we go. So truck will be pointing right. Then we're going to try and program it so the truck receives a broadcast. So we go back to events, and then not broadcast, but when I receive, I don't want to do anything when I receive Avery's turn. I want to do something when I receive. This is just showing you that you can have 2 separate. When I receive truck moves. Okay, I could do something when Avery gets her number, but I want to move the truck when I receive truck moves. So the truck, when I receive that, is going to glide out of the screen. So I'm going to glide it out of the screen, which is X 400 or something like that. 500 I tried. Remember, things don't go fully out of the screen. You're still going to see the back of the truck. Scratch doesn't let you move things totally out of the screen because then you can't find it and can't grab it. So I'll try to move it out of the screen, but it won't go all the way. And then I probably should end the program, so I'm should go into control, and then end or stop all. So now I've got 2 broadcasts, and I've got 3 different characters or sprites. It's going to do Scratch's stuff, get your number, then it's going to broadcast, hey Avery, your turn. Avery's going to receive that broadcast and say, oh, okay, I'm going to take your number, add 1, tell you, and then I'm going to send a broadcast, hey truck, your turn to move. Truck receives it, truck moves. So what's your number? 54. Your number plus 1 is 55. Send out the broadcast for the truck to move. Truck moves. Truck does not leave the screen because I said they always, kind of leave a little edge hanging out there. And then I decided, hey, you know what? I can hide the truck at the very end. So that's another little command here. You can show and hide sprites. So I'm just going to take the hide, and before I stop the program, I'm going to hide that little piece of truck. So remember, it does things in order. So it's going to do the glide first, and then it's going to hide. So 88, move the truck, and then it disappears at the end. I think that's pretty much everything I did, just showing you all these different options. I might put up another game where shark eats divers, I'm not sure, but this gives you an idea how to repeat actions, how to nest things, how to make things move, how to make it look like they're walking or moving, how you use variables, how you use logic, everything goes step by step, how you broadcast things so that other characters can receive broadcasts and do different things. You can do a lot of fun stuff in Scratch. If you pardon the pun, I barely scratched the surface here. And I'd really like you to try some of those math problems with it. We're not going to mark any of them. It's optional, but it's fun. And this type of logic is really, really good for mathematical thinking because it teaches you to go through the steps very carefully. You know, you start at the top and you move your way down, and things are well ordered and make sense, just like a recipe. Again, it's called an algorithm. All an algorithm is just a recipe of steps, of things that your computer is told to do in a specific order to do something, to do a specific task. So I would recommend that you try them. This is the kind of video that you probably want to pause and you know, start and stop and whatnot. If you have any questions, you just let us know. Okay. Best of luck.